For this lesson, I want to start with a whiteboard activity about square roots and cube roots and roots that have something other than a 2. So the square root of 9x squared, we have talked about that in the past. The square root of 9 is 3. The square root of x squared is x. This means you are trying to find the cube root. What times what times what gives you whatever the radical is. Well, 2 times 2 times 2 is 8, and x times x times x is x to the third. So the cube root of 8x to the third is 2x. This means what times what times what times what gives you 81x to the fourth. Well, the x part is easy. And you might have to do a little bit of work to get that 81, but hopefully you can see that 3 times 3 is 9, times 3 is 27, times 3 is 81. So this simplified is 3x. So today we are going to talk about simplifying expressions with rational exponents. Rational, remember, means it looks like a fraction. When I'm simplifying rational exponents, I actually think about this particular one often. So what does this mean? It just means the square root of x. In other words, what is in the denominator is what the root is. And since the square root is a given, we don't have to have a 2 there. So x to the 1/2 means the square root of x. So the rational exponent rule states that whatever is in the numerator is on the inside, whatever is on in the denominator is what root you are taking. So for example, x to the 1/3 equals the cube root of x to the first. And that first is not needed, of course, so it's just this. And x to the 2/5 means the 5 is going to be on the outside and the 2 is going to be on the inside. Now, I want to point out that when I first started teaching this, I was not aware that most places actually have this in parentheses with the squared on the outside. Either way is correct. So an easy way to simplify with roots, if you're given this, an easy way to simplify is to just rewrite the expression using the equivalent exponent. In other words, look at this and apply the exponent rules you've already learned. So here, the cube root of x to the 9th, y to the 3rd, we can take that radical and have this in the denominator and then use my exponent rules, where if you're raising a power to a power, you multiply. So x to the 9/3, y to the 3/3. So it's x to the 3rd, y to the 1st. We're just going to be adding on to what we already know about exponents. So in this particular case, we have power of a power, power of a product, and simplifying this. So x squared to the 4th is x to the 8th. Y to the 1/2 raised to the 4th power, you multiply. So 1/2 of 4 is 2. And then we're multiplying that by y to the 3/3, which is just 1. So the final answer is x to the 8th, y to the 3rd. As a side note, my husband saw this page when I was putting it together, and he's like, that is really complicated. I would never be able to do this, but I know you guys will be able to. So here, this next example, we have power of a product going on here, power of a power. So I'm going to start simplifying that, the numerator first. So x squared, y. 2 times 1/2 is 1, so I'm just going to leave it y. And then this, remember, is just x to the 5/5, or 1. So now we have x squared divided by x. So x Why? Because of the division property, this is 2 minus 1, which is 1. So most of your assignment today is not going to be as complicated as these problems. It's going to either be like this, where you're writing it as a radical or simplifying, or this, where you're writing it as in exponential form. But for our examples, I thought it'd be nice to put it all together because some of them are complicated like this. So we're going to use power of power, power of product. So a squared to the 1/2, we could actually rewrite that just to remind you. A squared squared, that 1/2 means that 2 is right there. So that's a. Or we could think of it as raising a power to a power, so we multiply 1/2 of 4 is 2. And then this part, remember what is ever on the outside is in the denominator, inside is the numerator, so that's b squared. And then when we're multiplying powers with the same base, we add the exponents. All right, this example just has numbers. So we're going to rewrite it. 81. Remember the denominator goes here. The numerator, we can either write it on, I'm going to show you two different ways. We can either write it on the outside like that, or we can write it on the inside like this. Now, in this particular case, we'd have to do 81 times 81 times 81, and then find the root of 4. And if you have a calculator, that's doable, but this is so much easier because we know that this simplified is 3. So now we just have to do 3 to the 3rd power. 3 times 3 is 9 times 3 is 27. So I always do the root part first and then do the exponent part. Either way is correctly written. It's easier to simplify this way. Now one last thing, if this had been a negative, so a negative 1/3, that just means, like it did with negatives, that you're going to be taking the reciprocal of your final answer. So 81 to the negative 3/4 would be 1/27.